Good day, everyone. We'll continue with our discussion sa kaning topic on. So we are now on chapter 4, that is on capacitance and dielectrics. Okay. So we all know man, di ba, na much of the things that we now enjoy today are made possible because of electronics. Okay. What we mean by enjoy is kanang na we are really entertained by, and not only entertainment but also of our daily use for survival. For example, they have example of these applications electronics. We have um, maybe our cooking wares, our um, electronic na mga induction cooker, rice cooker, and it has also become a necessity sa to ang everyday everyday use sa to ang gadgets. So everything were made possible because of the development and discovery of these electronics. And these electronics were even made possible, or it will not exist in the first place if not because of those people nga nag-study sa the fundamentals of electricity and magnetism. Okay. So because people really understood the fundamentals of electricity and magnetism, and that's why it developed into the application of our modern day electronics. Okay. So most of the things that we experience today as a living a comfortable life, as so to speak, because of the interplay of these concepts. Okay. And electronics electronics are made up of what we call circuits and circuit elements. We have uh, resistor, we have transistors, we also have semiconductors. And in a certain computer or cell phone, it is made, or your device is made of millions up to billions of these elements. And we also have capacitors. So for the discussion for today's uh, topic, we'll just be focusing on capacitors and its uh, counterpart, also the dielectric. Okay. So capacitors are devices that store electric charge. So example of where capacitors are used, it includes the following but not limited to. We have radio receivers, filters in power supplies. It also eliminates sparking in automobile ignition systems. It is also used as energy storing devices in electronic flashes. Kanang sudden burst bitaw of light or energy sa, I don't know if nakaapas pa mo ana kanang karaan nga mga ano bitaw old uh, old cameras na if i-click di mo siya, mo take siya og photo of yourself or of anyone or of anything, and it will mo send siya og burst like flash, tapos makasilaw gani siya nga flash, and that is made possible because of uh, capacitor, because capacitor can store energy and then it can also be released by by that mechanism katong mo flash siya. Okay, so the question is, how is this capacitor even made? So giunsa siya pag-create, and unsa ang iyahang physics behind, and unsa ang iyahang mechanism nga mag-involve wherein maka-create ka og capacitor. Okay? So fundamentally, a capacitor is consists of two conductors separated by an insulator or a vacuum. Now for this example, it is separated by a vacuum. So it's an empty space that are separated by a vacuum. So technically, these conductors are called plates. So kanisha, this is plates. Right? So these are metal conductors of opposite charge. So we have positive and negative. So when the conductors are charged, the plates carry charges of equal magnitude and opposite directions. So having a net charge of zero ang capacitance or a capacitor. So in effect, there is a potential difference that exists between the plate. So na potential difference because positive Q is of high potential and this is of low potential. So na kay potential difference, right? And the electric field is moving this way. Is the direction of the electric field. Okay? And if you put an electron here or a positive charge, it will tend to move this way. Okay? If an electron negative, it will tend to move this way, opposite sa direction sa electric field. Okay? So this is what we discussed before. The electric field, the direction of the electric field is always from the higher potential to low potential. Okay? So as what I've said, the capacitor has this opposite charge, so it has high potential here and low potential near the pit. This is negative Q. So in other words, if we have this process, okay, we actually store a charge Q on the capacitor, or we can say that the capacitor has a charge Q. Okay. So the capacitance, so in a capacitor na atay measurement sa iyang energy storage because capacitance is the uh, the ability to store charge also or to store energy. So it has a unit and it is called capacitance. Okay? So the capacitance of a capacitor is defined as the ratio of the magnitude of the charge on either conductor to the potential difference between the conductors. So it's the ratio between the charge stored and the potential difference of the capacitor. Okay? And the standard unit, the international unit of capacitance is farad. And for most application, kaya ang pag-fabricate ani niya is ano man siya, medyo lisod. But in actual fabrication sa imuhang capacitor, the unit is actually in terms of microfarads because it is very large, kaning farad. So you will see if sa inyong if naka-experiment mo before og electronics tapos nagpalit mo capacitor, ang itsura sa capacitor is usually kana man ang siyang inaani bitaw. This is kind of flat or katopong cylindrical, right? And you will see ang iyang technical specifications, ang iyang measurement is in terms of microfarad or picofarad. Okay? So microfarad is times 10 to the negative 6, while picofarad is times 10 to the negative 12 or negative 10, and I forgot. I think it's negative 12. Okay? So capacitance will always be a positive quantity. Okay? And the capacitance of a given capacitor is as I've said, is the ability to store charge or to store the amount of energy, okay, per unit of potential difference. Okay? So pila yang na-store na charge per unit amount of potential difference. Okay? So the greater the capacitance, the greater also is the magnitude Q of charge on either conductor for a given potential difference delta V. And another important thing about capacitor is that its capacitance depends only in sizes and shapes of the conductor, which you will know later, but we will not uh, go down or dig into the details because it involves a lot of math, a lot of calculation. So what we are going to do today is just to see capacitor and understand it in uh, generally in a concept siya nga manner, okay? Although naa siya gamay mga equation but more on the calculation sa electronic circuit na, but not on the capacitor or capacitance itself. Okay, so we have this. So as you can see in this figure, each plate is connected to a terminal of the battery. So we have the positive charge is this plate is connected sa kaning positive and this plate is connected sa negative terminal sa battery. Now the battery is a source of potential difference. So this is positive, so there is money ang direction niya sa ihang electric field. Okay? So when the battery is turned on, it will create a it's electric field sa kaning direction, and it will cause a potential difference. But will cause a potential difference sa kaning region, right? We have a higher potential here, and we have lower potential at a distance t, and then ang area A is given by this is mo ni ang area sa kanang the capacitor is uncharged. Now when the battery establishes an electric field, okay, it will force the electrons to move. It will force the electrons to move onto the negative plate. Okay, this one. So this continues until equilibrium is achieved, and the plate, the wire, and the terminal are all at the same potential now. So at this point, there is no field present in the wire, and the movement of the electron also ceases. So the plate is now negatively charged, this one, and the other giving it positive. So in this final configuration, the potential difference across the capacitor plates is the same as the potential difference sa imong battery. So kung unsa ang potential difference sa imong source sa battery, o po na imong potential difference diri sa imong capacitor because this is just arranged in this way. Isa na ka element which is the capacitor. Okay. This is what I discussed kanina. So as I've said, the field applies a force on electrons in the wire just outside the plates. So kung tanawon akong i-drawing, akong tanawon ako kanina. So as I've said, the electrons will move from the wires, but this is the supply man siya. So padulong siya dinhi, so this becomes positive. So a similar process also applies sa kanina plate. Okay, so positive man siya, so the electrons here will be moving towards sa kanina plate, kanina source sa battery. So this becomes positive. So it is like devoid of electrons because most of the electrons transferred from this place up to sa kanina point. And kani siya is manubra ang electron, okay? So excess of electrons, deficit of electrons. That's why you have positive and negative here. So in that manner, you created a capacitor. This is like a mini battery. Okay? Because it stores a charge also. It stores energy. So we will not discuss this. Muna siya ang theory git niya sa pag-create sa capacitor ba na ang ihang value. This is for parallel plate capacitor. Okay? Meaning, duha ka parallel plate na gid siya na separated by vacuum. Then we also have this type of capacitor na cylindrical, and then establish nimo ang iyang potential difference, calculate siya. Okay? And then the capacitance for this type of capacitor na cylindrical is given by this. So take note, nalalahi ang iyang shape, nalalahi ang iyang value sa iyang capacitor, iyang capacitance. So mag-vary ang iyang capacitance depending sa shape and size. Take a look at this. B is the radius, outer radius, tara, and A is the inner radius. So if i-vary naman na siya, mag-change po yung capacitance. Then we have also a spherical capacitor. Mo ang value sa iyang capacitance. So mo matter gid ang iyang shape and size. Okay. So capacitors are mostly useful when connected to a circuit or a circuit element. So that's a specific function and purpose. So what we actually see usually as drawings and diagrams are just an abstraction of the actual network in a circuit. So makita mong circuit si klase ba, di ba, na giring-giring, tapos na ingon ana, tapos and other sort of circuit elements. So these are just abstraction. Okay? And muna siya ang mga symbol niya sa circuit element, abstraction niya. So in a circuit diagram, it has many circuit elements aside from capacitors, which uses circuit symbols to represent its various elements. For example, in this figure, can you see a capacitor symbol is given by this? So muna yung capacitor symbol. Then the battery is given by this, while the longer one is denoted as positive, the shorter is negative. So maybe longer stands for higher potential, okay? Shorter is for lower potential. And then the switch symbol na po na siya. If you connect this one, so if you have a closed circuit, if it's open, so walay current mo flow because it's open. So capacitor can be connected into different kinds of orientation niya. Pwede siya parallel, pwede siya series. Okay? So manufacturing companies produces capacitors with standard capacitances and working voltages. So naa na siya specific na standard na siya nga value gid ba. For example, let's say theoretically na atay capacitor nga ang iyang value sa iyang capacitance is I say 12 microfarad. Okay? Let's say 12 na ang uban na apoy 20 microfarad and so on. But you can never find kasi dili ka basa-basa makapalit sa electronic shop o pwede ko mapalit og 25.5 microfarad. So usually wala ingon ana nga type of measurement kay in multiples na siya of ingon ana lang siya. So what you can do to obtain these values, gusto jud ana nga value, then what you can do is just combine capacitors. Okay, combine mo siya in such a way kung produce ka ana nga value. And there are many possible combinations, but the simplest combinations are parallel and series connection. So muna itong i-focus karon sa parallel and series connection. So when capacitors are first connected in the circuit, okay, so as I've said kanina, similar atong nga scenario, when the capacitors are connected in the circuit, electrons are transferred from the left plates to the battery to the right plate, leaving the left battery positively charged and the right plate negatively charged. Okay? Parehaan. I have this one. Positive plate, a positive terminal, and then negative terminal. Okay. So in that case, when the capacitors are, as I've said, connected, electrons are transferred from the left plate to the right plate, so leaving the left plate positively charged and the right plate negatively charge. And the flow of charges ceases only, sumustop ang flow sa charge only when the voltage across the capacitors equals that of the battery. So, mo-achieve ang iyang equilibrium. So, meaning, the potential difference across the capacitor is the same such that each capacitor in the circuit equals that of the battery's voltage. Okay? So, we can say na delta V is equal to delta V1 is equal to delta V2. Okay? So, the same ang iyang voltage because parallel man ni siya nga connection. So, kung unsa ang battery sa imong unsa ang voltage sa imong battery, that would be the voltage sa kani nga element. Okay? So, we can also say that the total charge is equal to the sum of the charges on the capacitor. Okay? Kumbaga natunga siya. You have your total charge coming from the battery. Na-divide na siya sa imong individual capacitor. We have this capacitor and this capacitor. So we can say that the total charge Q is equal to Q1 plus Q2. Let's say this is Q1 and then this is Q2. Okay? So we have this. And then we know nga ang formula sa Q can be related into capacitance because C is equal to Q over delta V. Tama na, diba? So we can substitute it here. Q is just C delta V from this equation, right? Q is equal to C delta V. So this is also C1 delta V. Delta V1 is the same as a delta V. Delta V2 is the same as a delta V. So we have plus C2 delta V. Okay, so mag-cancel ang mga delta V. Therefore, we have the total capacitance is just the sum of individual capacitances. Okay, so we have this relationship or equation. So, or what we call the C equivalent. Okay, so the total capacitance or the equivalent capacitance for that circuit arranged in parallel connection is given by this. I-add na nimo ang C1 o ang C2 or it could be kung daghan siya. So we have kung daghan siya, pwede sad siya C3 plus and so on, Cn. Okay? So we have this equation. So muna akong na-discuss kanina. So you have your C1, you have your C2. So we can get the equivalent capacitance ani mausa siya. We have this. It's just C1 plus C2. Okay? So the equivalent capacitor must have exactly the same external effect on the circuit as the original. So the total or the equivalent capacitance is greater than the individual capacitance. We can also arrange this one in series. Okay? But before that, let's have a quick example sa parallel. Okay? So take a look at this. So from this figure, we let C1 to be 6 microfarad and C2 to be 3 microfarad, and the potential difference supplied by the battery is 18 volts. So 18 volts na siya. So find the difference, find the equivalent capacitance, and then find the charge and potential difference for each capacitor when the two capacitors are connected as shown. So using the previous equation, katong CEQ equals C1 plus C2, we can get the equivalent capacitance for this. So mahitabuan na is imo siya i-combine, mahimo na siyang Ihang drawing niya, may mo siyang this. This is your CEQ, which is C1 plus C2. And of course, the battery is just V, which is 18 volts. Okay, so we can do that by just simply adding these two terms and these two capacitors. We have 6.0 microfarad plus 3.0 microfarad, which gives you 10 microfarad. Okay, and the potential difference across each of the two capacitors would be the same. Okay, so ihang V ani is the same, right? This is also VAB. This is also VAB. So for the charges Q1 and Q2, tara, have Q1 and Q2. So what is Q1 and Q2 sa kanang na scenario? They are directly proportional to the capacitances. Okay, so to get Q1, okay, so to get Q1, ato nang gamiton ang formula sa capacitance. This is just C1 times V. We already know what our C1 is. It's given. So we have 6.0 microfarad times the potential is just 9. Oh, sorry. The potential is 18. Sorry, 18 volts. And that would give you 108 microcoulomb. Okay? Or 108 times 10 to the negative 6 coulomb. Q2 would be the same fashion. C to V, you have 3.0 microfarad times 18 volt. That will give you 54 microcoulomb or 54 times 10 to the negative 6 coulomb. Okay? So, makes sense po siya because C1 is greater, right? C1, the capacitance is sa C1 is greater than C2. So, capacitance is the ability to store charge or energy. So, we can also directly conclude na ang Q2 is greater than Q1 as we've seen here. Oh, Q1 is greater than Q2, I'm sorry. So, tara, this is greater than this. Okay. Continue. Now, let's continue on capacitor arranged in series. So, similar lagi hapon siya sa capacitor na nila ang arrangement. Tara, series connection siya. So, when a battery is connected to the circuit, the electrons are transferred from the left plate of C1 to C2, right plate. So, as this negative charge accumulates on the right plate of C2, an equivalent amount of negative charge is removed from the left plate to C2. Tara, C2. Leaving it with an excess positive charge. That's why we have, for the left plate sa C1, we have positive. The right plate niya is negative. And ang iyahang condition sa left plate is positive here. This is negative. So, unlike sa parallel, na ang total charge niya is just Q1 plus Q2, for this case, ang total charge niya is the same. Okay, arrangement siya in series. So, ang source charge is of course the battery. So, if you have here, ang total charge niya, ang charge nimo is total is just equal to Q1 is equal to Q2. Okay. But the potential difference is not the same. Divided siya. So if you have delta V total, it's just delta V1 plus delta V2. Because this capacitor acts like a resistor. Okay? So divide ang imuhang potential difference, right? Okay? But the total potential difference is muna siya ang source sa battery. So this is what I've said kanina. Have that one. Well, the total charge among a total battery, you have total is equal to delta V1 plus delta V2. This is plus. Okay. So we can get a relationship between delta V and capacitance. C is equal to Q over delta V. Or we can say that delta V is equal to Q over C. Tama? So we can use it here. So delta V total is just Q total over C equivalent or C total. Okay. This one is Q1 over C1. I hope naka-follow ra. This one is Q2 over C2. But since we have this relationship na Q1 is equal to Q2 is equal to Q. So kani siya is equal na tanan. So mag-cancel na siya. Leaving us with this 1 over C equivalent equals 1 over C1 plus 1 over C2. So simply speaking, you can get the equivalent resistance from here to this. Just have to take the reciprocal. Okay? And then if imo na siya ma-add, then imo na siya i-reciprocate na dayon. If you have actually ang anak naman na siya 1 over ECQ C1 C2, right? We have C2 plus C1. Then if you want to get the C equivalent, you can have C1 C2 over C2 plus C1. Okay? So this is only true for duha ka element, but if pwede po ta magdugang 1 over C3 and so on, 1 over C sub n. That's the general formula of finding the equivalent resistance of equivalent capacitance of a capacitor arranged in a series connection. Okay? So mo ni siya. So we'll have an example sa one. So from the figure, actually the same siya og value, di ba, kanina? The same ani. Gi-series lang siya. Okay. So we can get the capacitance, equivalent capacitance by this formula, using this formula. 1 over C1 plus 1 over C2. So that would be 1 over 6.0 microfarad plus 1 over 3.0 microfarad. Okay. So if you get a calculator or mo siya isolve by hand, pwede na sa the equivalent capacitance is just 2.0 microfarad. So kamo na lang solve ani ha. Makuha na ninyo this one, 2 microfarad. Then how about the charge and potential difference for each capacitor? Tara. So kay man ta sa series connection, your Q total is just Q1 equals Q2, right? or you can get the Q equivalent. Q equivalent or Q total. Okay. Formula niya is just C equivalent, which is mo ni siya, nakuha na to, times the potential difference. If you get the Q equivalent, you will also get the Q1 and Q2 kay the same naman na siya. So we have 2.0 microfarad times the potential difference across the battery is 18 volts. So this is 36 microfarad. And so this is also equal to Q1. This is Q2, the same, ang ihang Q1 o Q2. Now, how about the potential difference? Walahi na siya. Because the potential difference is different across C1 and C2. Okay. So let's take a look at V1. V1 or VAC. Okay. You have VAC. Okay. Kana siya nga kuan or VAC or V1. Then VCB or V2. Okay. Same na. So for V1, itong gamitin ang formula sa capacitance, right? Ang formula niya is C equals Q over V. Therefore, V is equal to Q over C1. Okay, Q1 over C1. Where Q1 is just 36 katong total. So 36 microfarad. Oh, microfarad. Sorry about this. This is microcoulomb. Microcoulomb. Okay. C1 is 2.0 microfarad. Oh, sorry. This is equivalent. The C1 is 6.0 microfarad. That will give you 6.0 volts. For V2, we have Q2 over C2. Q2 is the same sa Q1, so we have 36 microcoulomb over 3 microfarad. Right? That would give you 12.0 volt. So this is 6.0 volt. Okay, so for kani siya nga portion sa kaning capacitor, C1 naa siya 6 volt, right? Sa C2 po naa siya 12 volt. If i-add nimo siya, it gives the total 18 volts. Right? 18 volt na siya. Okay. So that's it for this example. Now, as a quick exercise, you can actually pause this video and try to check if nganong kani siya starting from this, naabot siya anim. Okay? You try to do it on your own and check if sakto ba yun siya. Okay, simplify naman na siya. This one, ang process na naman din. This one is parallel. So, mausa na siya. This one is parallel, mausa. So, that's why you have this already. Okay, nausa na naman ni. This one is pwede mausa through series connection. Series, you have this. And kani is parallel man na siya, mausa. That's why final you have this. Giving you with a final capacitance of 6. Okay. I hope you can do that on your own. Okay, we'll not discuss this anymore. Let's talk about some applications sa capacitance, ang capacitor. So muna ang mga typical na mga shapes and sizes sa capacitors that are present in in any electronic device. Could be your rice cooker, microwave oven, refrigerator, any electronic gadget or device. So naan siya. Okay. So pwede mo mangukay sa yung TV, likod sa yung TV, makita mo mga bunch of those, thousands or millions of those. Okay. So capacitors are used in many devices that we now use today, such as this condenser microphone. I'm dying to have this one condenser na microphone. Nice siya nga microphone kay mo filter gid siya sa imong noise ba. So it makes use of uh, the concept of capacitance, capacitor, kind of condenser microphone. So inside the condenser microphone is actually a capacitor of rigid plate and a flexible plate. So na siya rigid and let's say flexible. So this is rigid, this is flexible plate. Puro sila conductor. Right? So inside the condenser mic is kani siya nga set up. You have a rigid plate and a flexible plate. So initially, when no disturbance or source of sound is present, these two plates are maintained at a fixed potential difference. So na siya fixed potential difference initially, wala siya disturbance. Now with the introduction now of a sound wave or source input, it causes the flexible plate to be agitated. So if mukanta na ka or mustorya, this flexible plate starts to move or wiggle. Move na siya back and forth. So if that is the case, move siya back and forth, your potential difference across it will change. Okay? So mo change ang iyahang potential difference because mo change po ang capacitance. Okay? Mo vary ang capacitance kay dependent mo siya sa distance, right? Changing the distance will also change your capacitance or potential difference. So in effect, the sound wave is converted to a charge flowing or a charge flowing which can then be amplified and digitally recorded. Okay? So change ang iyang capacitance and then it will send a charge dinhi and then that charge will be recorded, will be amplified and then that's why ang imong sound wave converted into electricity, electronic charge, and then that electronic charge, electricity, will be converted back to an audio or a sound na po through recording. Okay? So, thanks to capacitance, capacitor in action. So, another important application or contribution sa capacitor is imuhang touchscreen. Okay? So, yung mobile phones. So, basically, any device which has a capacitive touchscreen, kani siya. That's why it's called a capacitive touch. Okay? A capacitive touch. So you ever wondered how does your phone detects any activity or action that you do by just touching the screen of your device with your fingertips? So thanks to capacitors. So the exact position of a touch on your phone screen is detected by using an array of these capacitors. So sa imong screen, daghan na siya o divided siya into grids. Right? A single touch, mo touch ka din ha. So it distorts or changes the capacitance value for this particular location, and then your phone will definitely know asa nimo na siya gi-press, unsa na siya nga location. Okay? Nag-press dahil ka og any, let's say, sa kaning screen tagtanaw ka og something tapos gusto ka mo next sa part sa video, so kaning part is press nimo, that will be detected by the phone because of the change in capacitance sa kanang area. Okay? So ma-detect niya ang location. Exactly. So that's how capacitor work, capacitance. And sa actually ang capacitor po is they want to enhance the performance of capacitance. That's why they will try to introduce the dielectrics. So if you have your capacitor separated by a plate naman na siya, di ba? We have, let's say this is positive, this is negative. Sometimes they add a filler. It's like a material. They call this dielectric. So they try to add this dielectric to enhance the performance of capacitor. So mas modako ang iyang value sa capacitance. This is what we call capacitor. Okay? And the value of the capacitance is enhanced by this equation. So naa siya factor nga k nga modako siya. Depende sa material sa sa material sa imong dielectric. Okay? A kind of dielectric material mo differ siya mula lahi pa imong kapa. Okay? So K is the electric constant of a material. So the advantages of having the electric sa imong capacitance, sa imong capacitor, it increases your capacitance, it increases the maximum operating voltage, and also ang support mo niya kay mas lisod man mag-create ka og capacitor nga o mag-create ka capacitor nga walay sandwich ba walay in between, mas lisod siya i-hold, right? And this also allows the plates to be close together without touching because naman kay gi-inserts nga material sa in between. Okay. Kumbaga, mas lisod mag-create og kaning capacitor nga wala siya material in between. It's like free air na siya diha or vacuum. So magbutang ka og something in between the electric material, daghan siya advantages. Masayon siya i-create. At the same time, increase ang imong capacitance and increase the maximum operating voltage, increase performance. Okay, so the table shows the different dielectric constants and the electric strengths of materials. So we have air, vacuum, so we have 1, and then bakelite, we have 4, and so on. So different values, different ang iyang electric constant that would give you different value of capacitance. Okay. So that would be all for this topic. So short lang. So in summary, capacitor is made possible because of the concept that we discussed about, right? Electric potential, electric field, right? And of course, charge. And when you create this type of material, kaning capacitor, you have positive Q and negative Q. So, daghan na kasi application sa modern society today. Okay? So, as what I discussed kanina, daghan kasi application and gamit kay siya sa imong electronic circuit. This acts as a filter, ang imong capacitor. It also acts as an storage of energy. It gives energy burst. That's why na kay flash sa imong camera. And it also acts like a detector sa imong cellphone and imong touchscreen nga any touchscreen nga device, TV baka so that are made those are made possible because of the invention of the discovery of this capacitor, and that this capacitor is very simple lamang yun ang iyang pag-fabricate, di ba? For as long as you know this following concept. Okay? So fundamentally, it all boils down to electricity and magnetism. Okay? That's why we have electronics today. And electronics today, it really made our life comfortable and easier. Sakto ba? Na comfortable ba atong life? Of course, easier. But as to the impact sa society, dako ay siyang impact. Pero it's another story na po na ang iyang impact sa ato ang mental because isa side topic na siya nga ng discussion na sa STS na siya, right? Science, Technology, and Society. That science should should not be able to control us, but we should be able to control science for the development of our society. Okay, so that's all for today, and see you on our next topic. Stay safe and God bless.